What do you notice about the lengths and the angles of each triangle? Draw 3 different triangles in the boxes that I gave you. Turn and talk to your team, please. We're going to go over the instructions first. Investigation number 1. Shh. To discover the relationships between the lengths and the angles, we're going to start with a little spaghetti noodle, and I'll pass pieces out. The first thing you're going to do is you're going to measure your spaghetti noodle, okay? You're going to measure it in centimeters. You need to write down your measurement. Then you're going to break the noodle in 2 spots, then measure each piece. You're going to put your measurements in the first spot, and then you're going to write down your teammates' measurements. Some of you have 4, some of you have 3, but you're going to write it down. And then I want you to answer this key question. From the pieces that you made, can you make a triangle? And we're going to look at that, okay? Do not break all your noodles the same, okay? For this next part, have someone at your team grab a calculator. We will need a calculator to test some of our observations. The sum of the 2 shorter pieces must be greater than the third piece to form a triangle. So my groups that did not get a triangle, test it out. Test it out. If you got no, it does not make a triangle, add the 2 shorter. Is it greater than or less than? Does it work? Test it out with your calculator right now. Uh-oh. What if they equal it? Does it make a triangle?
It makes an all equal sign.
It has to be greater than. It cannot be equal to. Let's do this first one together.
Oh, I thought you said if all sides.
No. 4 plus 8 is what? 12. Is 12 less than 16? Yes?
Yes.
Does this make a triangle?
No.
Add the 2 smaller pieces together. 3 plus 5 is 8. Hey, 8 is greater than my third length, so yes, this will make a triangle. All right? Again, you're always adding the 2 smaller pieces to see if it's greater than the third one. Here, we get that they're equal. Will this make a triangle? No, it will not. It will not make a triangle. This is example 1. We're just looking at basic lengths. You don't have to draw a picture. If you'd want to draw a picture, you could. But we're just using that basic observation that we saw in investigation 1. Example 2. Let's determine the possible lengths for a third side of a triangle. What lengths are possible for the third side if the other 2 sides measure 15 and 16? I want you to turn and talk with your team. How will we answer this question? What should we do? So we agreed that we have to add up the 2 shorter sides, the ones that are given, 15 and 6. And we're saying that the third length has to be less than 21, or it could be 21. To find the other end, right, I would do 15 minus 6 to see the minimum that third side could be. You're going to write it as an inequality, and this is why we're looking at triangle inequalities. This is an inequality. This reads 9 is less than x, which is less than 21, or my third side, x, is in between 9 and 21 as a possibility. Questions on that example? Try this one now with your team, please. Please check your work. Check it. Questions about the first investigation? All right, let's look at investigation 2. Investigation 2, I've got some triangles drawn here for us. We need to measure each side in centimeters. We need to measure each angle. Then, we're going to look at the relationships and complete these statements below. Let's just start by measuring the first one, ABC. So you're going to measure with centimeters. I'll get the protractors. Ready, set, go. After you measure, discuss the two observations.
So, can they?
Hey, let's talk about investigation number 2. So stop what you're doing. Put your pencils down, put your protractors down, put your rulers down. Let's discuss this. I took these measurements from this team over here. The largest side of the triangle, the largest side, is found opposite of which angle?
The largest one.
The largest angle. Watch, look at this. C is 80. The largest side is 5.2. Is 5.2. The largest side is found opposite of the largest angle. The smallest side of the triangle is found opposite of the what? The smallest angle. 40 is my smallest angle. 3.5 is my smallest side. Make sure you have that written down. More triangle properties that we're going to be using. Any questions? Let's go look at example 3. Okay, we're not looking at the homework. We're looking at example 3. List the angles of the triangle in order from smallest to largest. The angles now. What are we given though? The sides. So which one is the smallest side? Which one is the smallest side?
15.
Oh,
AT. Segment AT is 15, and that's the smallest side. Which angle is across from that?
TB.
Angle TBA, right? Angle TBA. Or we can just say angle B. Do you all see angle B? Okay. Now, what's the one in between? Not our largest, in between.
AB.
So the next side would be AB, right? AB is 20. What's across from that?
TB.
Angle T, right? It's across from it. Our last angle would be angle A. It's across from 25. Any questions on seeing those relationships? Do we see it? B is the smallest because 15 is the smallest side. So this example, we took the sides and listed the angles. Are you ready for number 4? Number 4, we're going to list the sides in order from smallest to greatest. But what do we have here now?
A right angle.
Right angle, so this means it's 90. How can I figure out this angle? You need to name your side lengths with segment notation, like we did earlier this year. BU is just side.
Oh my gosh, I just don't get
It's
it.
not
Why do they have
in.
to use these? It's literally B, U, and double B's.
All right, we got one more problem. The letters in the figure represent the segment lengths. So X, Y, and Z are these segments, okay? V, W. Write the letter in order from least to greatest. What I would recommend is you start with individual triangles. Let's see what you can do in your teams. Ready, set, go. When your team is ready, you can check it out. These are the 2 separate triangles listed from least to greatest. Before I let you get to work on your homework, let's just summarize what we saw today. We looked at side length relationships in that first investigation. We said the sum of the two shorter pieces, what? Must be greater than the third piece. In order to make a triangle. Okay? And these are all triangle properties here. We just had 2 observations at the end of investigation 2 about the angles. The largest side is across from the largest angle. The shortest side, or smallest side, is across from the smallest angle. Some things that we reviewed today. We reviewed segment notation. How do you write a segment? How do you write an angle? How to use a protractor. All these things that we talked about earlier this year, we used in today's lesson. Your homework, we got about 10 minutes. Let's get started. It's 1 through 10. Homework, 1 through 10, and it should be on the back of that second notes page.